Good morning. I'm Devasena. In this lecture, we are going to discuss about temperature control interfacing with 8255. This topic is present in the subject mechatronics. Before going to study the temperature control system, let us see the block diagram of microprocessor based process temperature control system. It is capable of controlling more than one physical parameter. Such systems are commonly known as data acquisition and control systems. In these systems, analog signals from various sensors are converted into digital values. These digital values are read in and processed by the microcomputer. The keyboard and display in the system allow the user to enter set point values, to read the current values of process variables, and to issue commands. Relays, DA converters, solenoid valves, and other actuators are used to control process variables under program direction. Temperature control system involved interfacing successive approximation analog to digital converter, and typical method of measuring and controlling the temperature using microprocessor. A digital computer uses binary values, but in physical world everything is analog. Temperature, pressure, humidity and velocity are few examples of physical quantities that we deal with every day. Temperature measurement is of great importance in industry, as most of the processes are temperature dependent. A number of devices and schemes have been used over the years for the measurement of temperature. Typical sensors include devices like thermocouples, thermostats, RTDs, and semiconductor sensor. As an example, let us study the microcomputer based temperature control system to control the temperature between 0 to 100 degrees Celsius with on-off control. The figure shows the temperature sensing and the heater control circuitry using on-off control. Here is a representation of temperature sensing and the heater control circuitry using on-off control. In this diagram, we are having temperature sensing circuitry, ADC circuitry, on-off control circuitry. These things have been interfaced with 8255, from where it has been further interfaced to microprocessor. It may be 8085 or 8086. It includes sensing circuitry, analog to digital converter, circuit required to drive the controller. Sensing circuitry. The sensing circuitry consists of instrumentation amplifier using transducer bridge. Here is the sensing circuitry. RTD, that is resistance temperature dependent, is used as transducer whose resistance is changed as a function of temperature. R suffix T is equal to R naught into 1 plus alpha T, where R suffix T is the resistance of RTD at temperature T. Alpha is the temperature coefficient of RTD. Its value is 0.0039. R naught is the resistance of RTD at 0 degree Celsius. Delta T is difference in temperature, that is T minus T naught. At 0 degrees Celsius, resistance of RTD is 100 ohms, and at 100 degrees Celsius, resistance of RTD is R suffix 100 is equal to 100 into 1 plus 0.0039 into 100, that is equal to 139 ohms. At 0 degrees Celsius, bridge is balanced. So output of bridge V suffix AB is 0 volt. And at 100 degrees Celsius, V suffix AB is equal to VDC into R3 divided by 1 plus R3 minus VDC into R4 divided by R2 plus R4, that is equal to 5 into 1000 divided by 1100 minus 5 into 1000 divided by 1139, that is equal to 0.556 voltage. Now the instrumentation amplifier gain RF divided by R1 must be chosen to get 5.12 volt at 100 degrees Celsius. RF by R1 is equal to 5.12 volt divided by 0.1556, that is equal to 32.89. If R1 is equal to 1K, then RF is equal to 32.89K. This value of RF is not available as a standard value, so it is necessary to get this value by adjusting trim pot. To convert analog signal into digital signal, 8-bit ADC 0808 is used. ADC 0808 has 8 input channels. So to select desired input channel, it is necessary to send 3-bit address on C input, D input, A input. Here is a representation of analog to digital converter. Port lines PB0 to PB2 are used for this purpose. Schemic trigger input inverter circuitry generates 300 kHz clock, which is required to operate ADC 0808. The Zener diode and LM308 amplifier circuitry is used to produce a VCC and plus V reference of 5.12 volt for the AD converter. With this reference voltage, the AD converter will have 256 steps of 20 millivolts each. After at least 50 nanoseconds, this address must be latched. This SOC is achieved by sending ALE signal using port B line PB4. After another 2.5 microseconds, the start of conversion must be sent high and then low. Port C line, port B3 is used for this purpose. The end of conversion is detected by port line PCO. The figures show timing diagram for ADC 0808. Timing waveform for ADC 0808 representation here. As shown in this figure, solid state relay is used to switch on off heating element. Relay is energized and de-energized using transistor switch, which is controlled by port C line PC7. When PC7 is high, there is a sufficient base drive to run transistor in saturation, that is an on condition, and when PC7 is low, transistor is in cutoff, that is off condition. Thank you very much for listening this lecture. If you like this lecture means, kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.